Now we're going to look at an averages problem and do this with Z-calc so that we can later see how small sample tests are done with the rest of the t-distribution. Alright, this problem goes as follows. Last year in the Birmingham MSA, average giving to the United Way was $50 per employed person. This year, suppose that a recession is imminent in the local economy. A sample of 100 employed persons is taken, and it is found that on average they intend to give $47.21 with a standard deviation of $13.76. Using an alpha of 5%, is there any indication that average giving will decline this year? Clearly it's an average, so what average appears several times. This is going to be a one-tailed test because it talks about a decline. Will there be a decline? Okay, so let's write down our sample data. Alright, so sample in 100, X bar at 47.21, and S of $13.76. And we were asked whether there'll be a decline in the average from $50, the past average. Alright, so the word decline tells us it's a one-tailed test. It's a directional question. It's not whether it's equal to something versus not equal. And then we go through the routine and find out which tail test it is. Remember, we want the sample value and the critical value both on the same side of the distribution. The easiest way to handle that is to go through the following. First, you write down your sample bit of information, X bar 47.21, and compare that to the 50, and clearly it's less than the 50. Alright, so the Z-calc that we will work out later will be negative, and we want a negative critical Z value. So clearly we're doing a lower tail test. And the alternate, as with all one-tailed tests, will follow whatever happens here in the sample. So in the sample we have X bar less than 50. In the alternate we have the population equivalent of that, with the true average mu being less than 50. Okay, now we're ready to write down our hypotheses and put quick interpretations there, which will help us when we do our decision rule and decision. So alternate is easiest to do first, less than 50, and so the null complement of that, mu greater than or equal to 50. So mu is the new average, the 50 is the old average. So if the new is less than the old, there's going to be a decline. Remember, this is intended giving. And if the new average is greater than or equal to 50, the old average, we'll say no decline. Next step is to draw a distribution of the Z distribution, standard normal distribution. The middle of the standard normal is 0. Remember, we're doing a lower tail test here with an alpha of 5%. And so we want a critical value down here. From the tables you'll find that Z with 5% is 1.645. Alright, so we have a lower tail test now, so this is going to be negative 1.645. Negative values, of course, less than the 0. So a decision rule will be based on this diagram. If the z-calc is greater than the negative 1.645, do not reject the null. It's possible there is no decline. If z-calc is less than minus 1.645, it is likely there is a decline. Okay, so let's now write that out. Decision rule. So if z-calc is greater than or equal to the negative 1.645, null is possible, so do not reject the null. Okay, it is possible. Null is true, it's possible. There is no decline. Actually, there will be, since it's intended giving, will be no decline. As long as people's views hold the same. Alternatively, if we get down here where the alpha is, if z-calc is less than the negative 1.645, then we're sufficiently far enough below the hypothesized value of 50 so we can reject the null and in its place accept the alternate, and for the interpretation it is likely that the alternate is true, is likely there will be a decline. Alright, now when we're doing the test with z-values as we are here, the next step are calculations. First calculation will be the S of x bar, same as before, s divided by the square root of n. S in this case is 13.76 and divided by the square root of the sample size of 100. Makes the calculations easy. That's 1.376, and then we're ready to do the z-calc calculation. Alright, and that's x bar minus mu divided by s of x bar. Alright, x bar is the sample average given to us in the problem, 47.21 minus mu, value from the null hypothesis, the $50, the old average, divided by the standard deviation, 1.376. Right, going to Excel now to work this out. This equals 47.21 minus 50, close parentheses for the top line, the numerator, divide by the standard deviation, 1.376, and that's a negative 2.028 to 4 significant places, so 2.028. Alright, now we're ready to make our decision. Scroll back to the diagram. Alright, negative 2 will be somewhere down in the lower tail, outside the acceptance region. So we're in the rejection region now. So we follow part 2 of the decision rule. decision. Since zcalc is negative 2.028, which is less than the negative 1.645 for the critical value, we're far enough below $50 we can reject the null and accept the alternate. Okay, and the interpretation, it is likely there will be a decline. And that's the end of that problem.